After this, we're going to look at effects of force. Okay, effects of force. Force cannot be seen, but its effects can be felt. Anybody here ever saw force? You can see force, but you can see the effects. Where the force acts on an object, the force can change what? Can you tell me? Shape, size, and motion. Okay, good. Okay, now, when you have a toy car, when you push the toy car, what do you see? It moves, right? So there is a motion effect, right? Effect. Okay, look at C. Increase the pushing force and observe the change. What happens if you push harder? Faster, right? Okay, push the toy car again and ask the student to block. So what happens? Work, stop. Push the toy car again, ask the student to push the car from the side. Okay, this is the car, you push it this way, and then push it in from the side. What happens? It will change shape, right? Sorry, change direction. Right, change direction. Okay, so from here we can make observation. Okay, the next thing. Effects of force. Moving a stationary object. Okay, initially this object is stationary. When you push it, what happens? It moves. Okay, this is situation 1 and this is situation 2. What do you see in situation 2? A boy is kicking a ball, right? So the ball moves from stationary. So this is the first effect. The next one is what? You stop. You stop the moving object. Right, so of course it will stop moving, right? Okay, this is another example. When the goalkeeper catch the ball, it will stop also. The next thing is what? Changing the speed. Changing the speed. Force from opposite direction slows down the object. Okay, when you put your hand here, it will slow down. Force from the same direction speeds up. When it is moving, and then you blow the ball, especially ping pong ball. So of course it will go faster, right? So this one it slows down until it stops. Then this one it goes faster. Okay. And this one changing direction. The ball is moving this way, and then you push from the side, so it moves the direction. It changes the direction, right? Easy or difficult? Very easy, yeah? Because we can see this in our daily life. This one also, you move it this way, then you kick it in from the side, so it moves direction. What about this one? Yes, changing the shape. Initially, in this round shape, when you push it, there is dents on both sides, right? Just the same as a ball. But if the ball is not fully inflated, then it's easier for you to push it. Squeeze it like that. Okay. How many effects altogether? 1, 2, 3, 4, 5. Okay, one more time. First thing is moving, then stopping, changing speed, changing direction, changing shape inside. Can you memorize? Okay, good. Actually, you should understand. Okay, the next thing is buoyant force. Okay, this time we are going to see more about buoyant force. Now the toy duck here is floating. So the weight is the same as buoyant force. Example given here, weight is 10 Newton, buoyant force is also 10 Newton. Okay, what about this one? This is a stone. The stone, of course, will sink, right? So which one is higher? Weight is higher, buoyant force is less. 5 Newton. Okay, from here we can make an equation. Buoyant force equals actual weight minus apparent weight. Okay, from here you see this example. This is buoyant, this is weight. Okay, this is buoyant force. So how do you know the apparent? You know what is apparent weight? Apparent weight. Okay, it's given here. Weight of an object immersed in fluid. So when, okay, as I mentioned before this, just now, if you try to lift an object or a stone from the bottom of the river, you find it easier, right? So at that time, that is the apparent weight. That is the apparent weight. Once the object is above the water surface, find it heavier, right? So that one is actual weight. Okay, that one is actual weight. So we can refer to this equation. Buoyant force is equal to actual weight minus apparent weight, or you can also write it as apparent weight is equal to actual weight minus buoyant force. Sometimes we rearrange it this way, easier for you to find what is the apparent weight. Okay, you can manipulate the formula. Any question? No question. Okay, good. Okay, this one you can see later when we do the experiment. Okay, you can see the difference of the weight. Okay, the next thing is density and buoyant effect. Okay, you saw just now the duck is floating, right? And the stone sink. What is the difference between stone and soy duck? The weight could be the same. The weight could be the same. Maybe this one is 10 Newton, is another one also 10 Newton. You said you saw just now that the weight is the same. The weight of duck is 10 Newton. The weight of stone is also 10 Newton. But the density is buoyant force. Okay, why the buoyant force is different? Because of one of the reasons is because of density. The density of the object is different. Okay, that's why the buoyant force will be different. So okay, this one you have to do the experiment, then you can see it later. Okay, today we don't do it yet, we do it later. So from here, okay, this is the part that you need to understand. See here, the object floats. Okay, actually in this case, let me explain it. Okay, if the object initially is here, and then it moves upward. When it moves upward, we can say the force is greater than weight. But once the object is floating, like this, so the buoyant force is equal to weight. This relationship only true when the object is moving upward. But once it is stationary on the surface, at that time force is equal to buoyant force is equal to weight. Understand or not? Okay, I think you can read this one yourself. 10 seconds, read yourself. In 10 seconds. Okay, understand? Do you understand? Okay, when an object is less than the liquid, it is pushed into the liquid. So what is happening here? Initially it is here, and then you push it. You push it down. So when you push it down now, it is in this new position, here. What happens next is the object will rise again. Right. Okay, that is the time where the force is greater than weight. When force is greater than weight. So I need to read the explanation here. It pushes the object up to the surface of the liquid, the object will float. Any question? What about this? Conversely, when an object is more dense than liquid, the buoyant force of thrust F is less than the weight of the object, it causes the object to submerge to the bottom of the liquid. I think you can understand this one, right? Easy, right? Any question? Okay, the next thing is value of density for different materials. Actually, you don't need to memorize this. This is only for information. Can you tell me which one has less density? Among the materials here, which one has less density? Cork. Cork is the least one. The most? Gold. Okay, gold. Gold has highest density. 19.3 grams per centimeter cube. Okay, this is the equivalent unit. 19,300 kilogram per meter cube. Actually, we can convert the unit ourselves. You know how to convert the unit? Okay. But let us try to convert the unit. Most students make a mistake here. This is only for revision. Okay, how do we convert? Okay, one. Okay, let me use red color. Okay. For example, 19.3 gram per centimeter cube. Okay. So you need to do two things here. First, convert 1 gram. 1 gram is equal to 1 times 10 power negative 3 kilogram, right? Is it true? Is it true or not? Is that or not? 1 gram, 1 gram, 1 gram is equal to 1 over 1,000, right? Right. But I write it this way. Same thing. Okay. 1 centimeter is equal to 1 times 10 power negative 2 meter, right? Is it true? 1 equal to 1 by 100 lah. Kan? Ni awak biasa pakai ni kan? Tapi awak kena biasakan yang ni. From now on, please use this one. It's more useful. Okay. Tapi since we have cube here, so you need to cube the unit. Cube unit macam ni. Faham tak? Cube dia punya unit. So dapat berapa? 1 times 10 power negative 3 times negative 2 negative 6 meter cube. This is 1 centimeter cube. Faham? Faham tak? Okay. So 19 So kita buat semula 19, mana tadi? 0.3, 19.3 gram per dengan centimeter cube sama dengan equal to 19.3. Tadi kat sini berapa? Time 10 power negative 3, betul? Kilogram. Yang ni, centimeter cube ni 1 times 10 power negative 6 meter cube. Faham? Faham tak? So, how do you solve this one? How do you solve this? 19.3 times 10 power negative 3 plus 6. Betul tak? Buatan jadi positif lah. And then you need kilogram, meter, ini positif, jadi negative 3. Betul? 19.3 times 10 power 3. 3 kilogram meter per meter cube. So, sebab itulah dapat 19300 kilogram meter negatif 3. Dapat ini. Boleh faham? Dia tak boleh, awak tak boleh convert straight away dulu dia ada step. Tak boleh belajar silap. Okay, faham Okay, done. Jadi, okay, now, what's this? Linson line. Where do you find this? Dekat ship dekat kapal. Dekat kapal tu, dia ada dekat bahagian tepinya. Sini. Dekat kapal ni, dia ada buat table. This is Linson line. What is Linson line for? See what we have here. Okay. This is TF. TF stands for tropical freshwater. T is what? Tropical zone. Summer. Winter. North Atlantic. Okay. Why do we need those lines? First, for safety reason. You can see this ship is loaded with so many containers, right? So, what happens is the weight increase. The weight of the total weight of the ship will increase, right? So, because the ocean here has different density depending on the weather, depending on the temperature of the surrounding, and also depending on the density. Actually, it depends on the density of the ocean, because sea has salt, right? So it has different density than fresh water. Fresh water doesn't have salt, so it doesn't have the density will be different. Which one is high? Which one has higher density? I mean salt water or fresh water? Salt water. It has higher density. If it has higher density, then the buoyant force is higher. Okay, buoyant force is higher. So we need these lines to make sure that at certain places, then we should not exceed that line for safety reason. Okay. You can see fresh water. Fresh water is on the top, right? What's fresh water? Fresh water. What does it mean by fresh water? Sungai lah. Sungai tak ada garam. So the density is lower, right? When the density is lower, the buoyant force will be lower. That's why it sinks more. Faham tak? Lepas tu dia tenggelam lebih dalam. Lepas tu level dia kat atas. Sebab the buoyant force is low, because the density of fresh water is lower. Faham tak? Okay, baca sendirilah. The difference due to temperature and concentration of salt. The density of seawater is different in different parts. Dekat lain tempat lain dia punya density seawater. Lepas tu kita ada North Atlantic dan sebagainya. Any question? Before we go on with the next topic. It can float. How it floats? Okay. Because of the overall density overall. Okay, let me explain a little bit here. Let's say we have a stone. Stone, right? A stone. It displaces less water. Displace. Displace apa? Displace. Displace tu dia ambil tempat. Batu tu dia ambil tempat sikit je. And the same okay, sekarang ni yang ni pula. Okay, katakan the same mass the same. Contohnya katakan sini 1000 kg batu ni 1000 kg. Kemudian ada boat. Boat pun 1000 kg juga. Sama dia punya mass. The mass is the same. But this one displaces less amount of water. Yang ini displace banyak. Maknanya katakan dia dekat sini air kan. Maknanya kawasan ini dia displace water. Ya, dia displace banyak air. More water. When it displaces more water, buoyant force will be higher. But buoyant force equals to weight of water displaced. Awak akan belajar masa tingkatan 4 nanti sebenarnya. Okay, orang tanya soalan tu kita juga. This one displaces less amount of water, so it has less buoyant force. This one displaces banyak kat sini. Kawasan yang tenggelam ni banyak. Jadi dia air yang sepatutnya berada di sini telah disesatkan ataupun displaced. Jadi buoyant force FB is equal to weight of water displaced. Ini awak belajar form 4 ni ya. Tapi saya explain sikit je lah. Sebab itulah yang ni dia float. Yang ni sink, yang ni float. Sebab weight force dia lebih besar. Dia displace lebih banyak air. Water. Bukan air je lah, water. Any kind of fluid. Including air. Okay, next is level. Level What is level? Pernah tengok ni? Pernah belajar tak? Masa dengar apa? Pernah lah. Tapi ada belajar formula. Okay, jadi maknanya tambah sikit lagi ya. What do you remember about level? How many types of level? How many classes of level? There are 3 classes of level. And we call it simple machine. Okay, we call it simple machine. Okay, let's try to recognize the term we use here. Effort. What is effort? What is effort? Force yang awak buat lah. Force yang awak kenakan. Force apply. What is load? Load tu apa yang kerja apa yang awak nak buat dia, nak angkat barang tu. Itulah dia load dia. What is fulcrum? Fix. Ini keyword dia tidak bergerak. Fix ini fix. Fix point. Fix support point. Okay. A lever allows us to do work easily. Pernah buat tak ni? Lalu buka T-Milo dan sebagainya. T-Biskut ke. Jadi, pernah buat? Tak pernah. Dia pernah, dia tak pernah. Sekarang ni dah jarang buat macam ni ya. Jarang nak pakai ni. Ni contoh lifting a heavy load. Okay. Awak pernah tengok dekat TV dekat ladang kelapa sawit macam mana dia orang nak angkat kelapa sawit masuk dalam lori. Biasa dia buat macam mana tengok? Yang saya biasa tengok dia ada satu macam besi tu, dia cucuk, kemudian dia angkat masuk kan. Awak rasa senang tu susah macam tu? Susah, berat tu kan. Jadi saya terfikir kenapa dia tak guna level macam ni. Kan? Dia design lah, jangan macam ni saja. Dia design sikit, sesuai. Kita boleh buat kerja lebih mudah kan. Mungkin antara dia awak cerita, boleh? Belajar fizik kan? Ini cara mudah lah, tapi janganlah buat. Adalah awak buat sesuai sikit, lebih besar ke, lebih mudah untuk angkat ya. Removing nail, kenapa buat ni? Kat sini, kat mana level, kat mana dia punya fix point? Fulcrum dia kat mana? Fulcrum dia tak gerak. Dekat sini lah fulcrum ni. Ini awak punya pause. Sini apa? Paku ni? Load dia. Okay, kita tengok satu-satu. Ini dah belajar. You have learned this, it should be easier. The first one is the first class level. Which one should be in the middle? Tengok yang dekat tengah ni. Fulcrum. Untuk second class, load kat tengah. And third class, effort. Boleh ingat tak? Kalau dah ingat, kalau for me it's easier for you if you write fly like eagles. First ni adalah fulcrum. Yang ni fulcrum, yang ni load. This one is effort. Yang dekat tengah. Fly like eagles. Betul tak? Awak nampak ayat aku boleh. Okay, let us look at the first class example. Flyers, one's in the middle. Fulcrum, load here, and the effort here. Okay, what about can opener? Fulcrum still in the middle, betul tak? Ini faham tak? Do you understand this one? This one is the first class level. Do you understand or not? This one? Yes. Okay, good. The next one is scissors. Scissors is the same as pliers. Fulcrum in the middle. Any question? No question. Okay, the next one is second class level, load in the middle. Okay, example, wheelbarrow, load in the middle. Right? And then the effort, you pull it upward. Right? So that is the effort, and the fulcrum is here. Nutcracker is also second class level. Kalau orang dulu dia pakai kacip. Pernah tengok kacip? Siapa pernah tengok kacip? Katakan. Kacip pernah tengok? Guna untuk apa? Awak pernah tengok? Awak tengok kat mana? Kalau orang Melayu dia dulu ada pakai lah kacip tu. Orang India tu tak tahu. Ada tak pakai kacip? Orang India ada pakai sirih tak? Tak ada? Untuk orang tu dulu ada je sah. Zaman datuk-datuk awak buat je kan. Itu pun example of second class level juga. Okay, the next thing is what? Third class. What is in the middle? Effort. Okay, effort. Ice stone. Effort in the middle, right? Ice stone. This one? Fishing rod. Fishing rod also the third class level. Why? Because you pull it here when fish is Betul kan? Okay, you pull it from here. Kan tu, tarik tengah ni. Jadi jadi third class level. Ini dia punya summary dia. Ini sudah kawan dia, very simple. Okay, seterusnya kita dah tengok moment. Okay, moment of pause. Okay, jadi moment of pause ni kita belajar next. Sebab dia agak panjang Kita nak baik kepada ni, tengok ni balik. Kita baik ni, jadi ada sikit lagi kita kena discuss. Apa dia punya okay, first class level. Apa dia punya advantage? Advantage dia. Okay, advantage dia ialah awak use less effort, betul tak? Okay, macam mana dia boleh produce less effort? Sebab apa? Contoh tadi yang kat batu tadi mana? Ni. Kat batu tadi kan. Dia, kalau benda ni menyusahkan, dia takkan guna lah benda ni. Dia kat tu dia kan. Sebab less effort. Sebab apa less effort? Sebab ini panjang. Distance of effort dia longer than distance of load. Sebab tu dia less effort is needed. That is the advantage of the first class level. So first class level punya advantage. Second class level. Apa ada punya advantage? Okay. Jadi apa? Yang ni pun sama juga. Less effort. Sebab apa? Sebab dia punya distance of effort dia lagi panjang daripada distance of load. Kita faham tak? Okay, dari sini tengok. Mana dia punya distance of effort? Distance of effort kita ukur daripada fulcrum. Sini sampai sini. Betul tak? Jadi distance of effort. Distance of load sini sampai sini je. Betul? Maknanya ini pun less of effort juga untuk second class level. Tapi yang untuk ini macam mana? Mana dia punya distance of effort dia? Distance of effort. Distance of effort dia macam ni aja, distance effort. Tapi distance of load dia panjang tu tak? Maknanya dia lagi susah ke lagi senang? Lagi susah. Lepas tu bila orang nak tarik ikan, susah nak tarik ikan tu tak? Orang tengok dia struggle kan nak tarik ikan kan? Walaupun ikan tengok tak susah pun. Betul tak? Tapi susah tarik. Sebab apa? Sebab third class level dia punya effort lebih besar daripada load. Tapi apa advantage dia? Ada advantage tak? Apa advantage? Advantage dia ialah, dengar advantage dia ialah dia punya movement sini sikit saja. Awak gerak sini sikit, tapi yang bergerak dekat sini banyak. Awak tarik sini sikit, tapi movement di sini adalah banyak. Pergerakan dia tu banyak. Itu advantage dia. Tarik sikit je, tapi yang ujung tu gerak banyak kan. Itu advantage untuk third class level. Tapi dari segi effort dia kena banyak untuk menggerakkan load. Itu dia punya disadvantage lah untuk yang ni. Jadi dia punya disadvantage. Okay. Boleh? Okay.